Hello guys, welcome back to Carry Code. In this video, we are going to see about one more project, that is diabetes prediction. And this is the dataset I just took here. I think this dataset is about only women, because if you see the variables here, the pregnancies, the glucose values, blood pressure, skin thickness, insulin, BMI, and then the age. This is the dataset I took here. It's having like 2700 rows, right? Let me import some basic packages here first, like pandas, numpy, matplotlib, and seaborn. Let me import them. Import pandas as PD, as we do in every project. This is the first step. C1 and this is like that. And then next step is to import our dataset. We use pandas to import the dataset. pd dot read csv healthcare diabetes dot csv like that, and I will be storing it in a variable called diabetes data frame like that. Let us see how this dataset looks using dot head, which returns the first 5 rows of this dataset. So you see the same thing in the CSV here. The ID, pregnancies, glucose, blood pressure, all these variables, we extracted them here. All this data. Let's see the shape. Dot shape like that. If you see, it has a 2768. It is same as this CSV file I took, because I imported the same file here. Let's see what type of data is there inside this dataset. Dot info like that. If you see, it has only the numeric types, not the strings or objects. So we don't need to convert them to again the numeric types, right? And then let's describe this dataset, and let's see some other insights, like the minimum value, maximum value, the mean values, those things. Let's see them. If you see, we got all the minimum, maximum, mean, standard deviation, the number of rows, every count here, right? We can apply some data preprocessing techniques using this data here to make our model more accurate. Okay, let's see for any null values in the dataset. I can do that using dot is null function and dot sum, as I do in every project. This will take the dataset and see if the value is null or not, and this sum will add all the null values, like the count of null values in the data frame. This is null will return whether the value is null or not, like true or false, and then it will sum up the true values. Let's see. I think we don't have any null values here, so it is 0 for every variables here. Let me use this function called drop duplicates to drop if there are any duplicates in the dataset, like diabetes df dot drop duplicates like that. Let me store it in the same variable, diabetes df, like that. Let's see the shape now. It is same, right? We don't have any duplicate rows here, so it didn't drop any rows. So as you observe here, the ID is nothing but the unique value for every row, right? So I don't need this in my model training, so I will be dropping that column now. And I will be storing them in the same variable here, like this. It should be capitalized. Let's plot some graphs here using seaborn to see how the data looks in visualized way. SNS dot pair plot of diabetes dataset. Let's see, it takes some time. We get all the plots corresponding to each and every variable, that is the column here. It's almost there. So it is here. You can observe these graphs for any relationship between the variables. That is, we need the outcome variable to be predicted, because this is the value which says whether the person is having diabetes or not. So we'll be using all other variables and predicting the outcome, that is nothing but the 1 or zeros. So if it is 1, the person will be having that diabetes. If it is 0, the person is not having the diabetes, right? So using all these variables, we have to predict the outcome variable. This graph looks very huge, right? So I want to find the correlation between each and every variable. So I can do that using this function called .core. So diabetes df dot corr like that. Let me store it in correlation variable like this, and let me show you the values using the heat map, using that seaborn dot heat map of correlation, comma n not equal to true. So we'll get all the values printed on the heat map, and cmap equal to green. So the heat map will be in green color. Let's run it. So this is the heat map and the correlation values between all the variables. We have to observe only the outcome variable here, as we are going to predict it. If you don't know about this correlation matrix, I will be explaining them briefly here now. If the value is very nearer to 1, we can say that the two columns or variables are positively correlated. So if one value is increasing, the other value will be also increasing. And if the value is nearer to -1, that is -1, then we can say the two variables or columns are negatively correlated. That's nothing but if one value is increasing, the other value will get decreased, and vice versa. And if any value is nearer to 0, we can say that the both columns are having very less correlation or no correlation at all. Okay, but in this case, if you see, the outcome variable is very much correlated, that is positively correlated with glucose, and also the BMI, also the age. So of course, I will be taking all the variables here. You can drop out some variables here, for example, the blood pressure and the skin thickness. It is very low, 0.07. So you can drop out and test it out. You can try out different models and comment down in the video what is the accuracy you got. Okay, so it's time to divide our x and y values here. So my y value, that is the independent variable, is nothing but the outcome, right? So I'll be taking diabetes df of outcome like that, and x values, other than outcome, we have to take all other variables, right? In this case, I'm taking like that. You can take using that correlation between the variables, you can choose the features you need. Okay, diabetes df dot drop off. I have to drop this outcome, and comma x is equal to 1, like that. Okay, let's see the data inside this x and y variables. You see, we dropped this outcome variable, so it doesn't have in this data. And y dot head, it is only having the outcome variable. Okay, we successfully divided the data into x and y values. Now it's time for try and test split. That is nothing but we have to convert our data into different sets, that is try set and test set. Okay, let me do it. From sklearn dot model selection, I can import this try test split like that, and I can call this function here try test split, and I have to send x values and y values. Also the test size equal to 0.2, that is nothing but 20% of the test set, and random state, this is nothing but how many times whether I run this cell, it will be taking the same data set, it will be dividing at the same point. So that's why I'm using this random state. And let me store these data sets in different variables like x try, comma x test, comma y try, comma y test, like that. Okay, let's run it. Let's see the shape for this training and testing sets. X try, comma y try dot shape. You see, it is having 2214 rows for training, and x test dot shape, comma y test dot shape, and the test set is having 554 rows. Okay, now I come up with a beautiful classifier here to train our model. Okay, so that is nothing but the bagging classifier from sklearn. Let's see how to import it. From sklearn dot ensemble, you can import this bagging classifier like that. Run it. Let me create an object for it, that is vc model equal to bagging classifier. I can give some parameters like n estimator, let's say 150, like that, and random state, let's say 2. The next step is to fit the model dot fit with the training data x try, comma y try, like that. So it should be t. So the classifier is ready. Now try to create the test data set. So we can use bc model dot predict of x test, and we can store the values in y predict like this. And let me print the accuracy here itself. I can import it from sklearn dot matrix. I can import accuracy score, also the precision score, like that, and also the confusion matrix. So we can be knowing how many values did our model predicted correctly and how many it didn't predict. Okay, let's print the accuracy now. Print of accuracy score, we should give y test, comma y predict, like that. Okay, then the precision value, print of precision, it is also same, precision score of y test, comma y predict, like that. Okay, then at last our confusion matrix of y test, comma y predict, right, like that. Let's see. Hooray, we got 99% accuracy. And if you see the confusion matrix here, it predicted everything correctly except these 4 rows, right? It predicted 4 values only the wrong way, except everything predicted correctly. So it has 99% accuracy, as if you can see here. But in some other videos, I have used one more method to find the accuracy, that is using that mean absolute percentage error. I can show you that one also from sklearn dot matrix import mean absolute percentage error. So using this error I can find the accuracy, right? Send the white test comma y predate accuracy equal to 1 minus this error. Okay, let's print the accuracy here. Accuracy comma accuracy. So if you see, it is same 99% accuracy. So let's quickly try some ANN model also, so we can see whether our ANN model will get 100% accuracy or not. So let's import the sequential from this TensorFlow. So from TensorFlow dot keras dot models import sequential, right? Also the dense layers and the dropout layers also we'll be adding them, so we'll be importing them also from TensorFlow dot keras dot layers import dense comma dropout, like that. Let's create a sequential model, sequential, like that. Let's add a dense layer here. Model dot add of dense with 50 neurons, maybe, on with an activation function of ReLU. The first layer is the input layer, so input dimensions equal to 8, like that. Then our second layer may be the dropout layer. Let me take a value of 0.6, okay, like that. And let me copy paste these two things 2 more times. So the second layer, this layer is not input layer, so I'll be removing that. Let's take here the 40 neurons, like that, and instead of 0.6, or let it be like that. Let me take another layer with 30 neurons and then dropout layer here, and at last let's take 25 neurons, the output layer with only 1 neuron at last here, like that. And we are using ReLU function everywhere. Okay, then the next step is to compile, right? So model dot compile. We can use our loss. I will be using as binary cross entropy, like that, and optimizer as SGD comma matrix equal to, let's say, accuracy. Okay, the next step is to fit our model. Fitting our model, x train comma y train comma the epochs, let's say 5, so it will be trained quickly, and batch size let's say 1, like that. Okay, let's run it. So it is training. It is only having the 5 epochs, right? So it will take a very less time to train. So the next step after the training is to predict our model, right, using the test dataset, right? So the model got trained well. Let's try to predict the test dataset now. Model dot predate of x test, like that. Let me store the values in ANN y predate, like that. Let's run it. So let me copy paste the same thing here, the accuracy. Let's see here how much accuracy it gets. So it is only 66% accuracy the ANN model is giving to us. So I can say the classifier model is far more better than this ANN model, right? Maybe we can try different layers here, the hidden layers, the CNN layers, everything like that you can use and try to make it with predicting with a more accuracy. Okay, let me store this classifier model using this pickle. Import pickle with open, let's say, diabetes model dot pkl wb yes f pickle dot dump of pc model comma f, like that. So it will create here the pickle file here. So I just want to create a small web app, so we can give the inputs there and check whether the person is having diabetes or not. Okay, let me open my VS Code quickly. Let me create a file here, web app for diabetes.py, like that. The first step is to import all the required libraries. So I'll be importing here. Let me copy paste here. So these are the required libraries as I have imported in the same way there. Extra thing I have imported here is the Streamlit. So the Streamlit library is used to build this web app for this kind of machine learning models. Okay, so let me give the title for this app, st.title of diabetes predictor app, like that. Okay, so for this app I just have to take input for all the variables, right? So let me copy paste them. So let me paste the input variables here. So to do the job quickly, I just copy pasted these variables here, the input variables, the pregnancies, glucose, blood pressure, skin thickness, insulin, age, BMI, everything. And if you see, st.test input is nothing but it will give an input box there in the web app, and this is the prompt we'll get, enter the value like that, and this is the default value we are giving it here. This is the first row values I'm giving in the each variable here, and at last I will be converting them to the flow type variables. Okay, then our next step is to import the model we have built, right? If you see here the pickle file, we have to import this file. Using the same pickle package, we can import it like this. So with open model name, that is the file name, and in the read mode, we have to open it. Pickle.load, we can use F like that. It will be stored inside this model variable. Okay, so using this model variable, we can read the data, right? So let me copy paste the rest of the thing here. What I did is I took all these input variables from the user, right? So I made them together into a 2D array here and stored it in X data. Then after I converted them to the NumPy array in the next step and stored in the same variable. And in the next step I used this dot predate to predict the outcome variable using all these input variables I have here, right? Then I just printing these prediction variables here. We don't need to do this. Just for debugging case I just mentioned there. And I'm using a subheader, so this will be the last value here. That is to say whether the person is having diabetes or not. So if the value of the predictions is 1, then it will say yes, the person is having diabetes, and if it is not 1, if it is 0, then we will be writing no. So the question, do the person have diabetes, for that question it will say no, right? Let's run this file now. You can use python -m streamlit run our web app name, enter. Okay, so it's loaded our web app here, it's still loading. So if you see here the diabetes predictor app, these are the input values, and at last we got the output here. Do the person have diabetes? Yes, it is saying yes. This is the first row value I took. So if you compare it here, the 6 148 72, the outcome is 1. So 6 148 72, if you see, the output is yes. So the person is having diabetes. So let's say I took the second values here, the 185 66 like that. So let's change them. 185 66 25 is 0, and let's say it is 26.6, and let's convert this to 0.3 and age of 30 or 31. See, it's already changed the value. As I changing all these variables, it dynamically predicting the outcome variable dynamically, continuously it's getting predicted based on the values I'm giving it here. So if you observe the second row value, the outcome is 0, so he is not having diabetes. So it is also giving the same output here. So because it is having 99% accuracy, right, so it's predicting very perfectly. So that's it for this video, guys. If you have any doubts, you can comment down below in this video, or else if you want to reach out to us, you can connect us in Insta. All the links will be available in the description. Please subscribe for more videos, guys. Thank you.